The band They Might Be Giants made a song called Who Put the Alphabet in Alphabetical Order. They were being a bit rhetorical in that one, but let's be a bit less rhetorical, asking the same sort of question here in chemistry. Who put the periodic table in periodic order? Well, Mendeleev, back in 1869, started arranging the periodic table by mass. Now, when he did that, he found that some of them had nearly equal masses. So he said, well, I'm going to have to sort these ones out by properties and group them in the same column as other things that have similar properties. As an example of that, cobalt and nickel. If you look at their masses, they're listed here in current periodic table order, 58.9, 58.7. You can see they're really, really close together. And in fact, if we went in just mass order, they would have been sorted in the wrong order, the opposite of the periodic table. But since you put them in the same groupings as other atoms that had similar properties, they ended up working out pretty well. Now, there are also a bunch of gaps in the periodic table, places where there's enough of a jump in mass, they said there's probably some sort of an unknown element that if we can identify it, it'll fit right here in this empty slot. And that ended up being borne out. Now, Moseley came along after Mendeleev, and he worked on the periodic table as well. But he reorganized it using atomic number in order. I also just thought I'd point out Moseley, he's a really cool guy, and probably would have been a major Nobel Prize winner if he had survived just a little bit longer. He actually came up with this result in 1913 based on some X-ray experimental results that he also interpreted to give a lot of other information to researchers as well. Left for World War II in 1914, and then died in 1915 at the age of 27. So you can see he was a pretty young scientist as these things go. And had he survived a little bit longer, he'd probably be one of the really big names that you knew from Chem 1. I just thought I'd highlight him as a result, give him some of his due. Now, the other neat thing that he did is he really gave some evidence that supported Rutherfords Model. I do want you to have the understanding that when we talk about these major experiments in previous chapters and previous videos, you know, those things were controversial at the time. They seem super obvious to us. Obviously, that's how the world works. But at the time, it was a really controversial notion. And Rutherford's model was still not strongly dominant in the field. People are starting to come around a little bit. But Moseley's experimental results really helped prove that, yeah, the plum pudding model is not correct. We actually do have a really dense lump of mass at the center. It turned out that that was a positively charged and neutrally charged mass with the electrons around it. But the whole idea that, you know, particles would ricochet off, and it was shocking because it was like a 19-inch shell bouncing off tissue paper. That whole experimental result was not convincing everybody at the time. But some of his measurements about the periodic table and the way that he did that actually gave some really strong support to Rutherford's model.